In our previous lesson, we learned that a loop is a set of instructions that repeats until a condition is met. We practiced simple problems like counting numbers or printing names. But in real life, loops are used for bigger tasks. For example, a cashier computes total for many items, a teacher averages student scores, or a dormitory system checks multiple RFID log entries. Today we will solve problems that require thinking, not just repeating. We will analyze the problem and create the flowchart. Get ready to think like programmers. So let's start with this problem. Create a flowchart that asks the user for a positive integer n, then computes and displays the sum of all numbers from 1 to n. Now, this problem requires us to let the user input a positive integer n, where n is a variable that will hold the value that the user inputs. Now, this value will be the one that we're going to compare inside the condition. So here, what it tells us to do is, if the user, for example, would input a value of 3, then our program would add all the numbers from 1 up to the value of n, which is 3. In this case, we are going to sum up all the numbers from 1, 2, and 3. So in this case, after execution, this would give us a value of 6. Now, let's create the flowchart for this problem. First, we need to have the terminal symbol. Then, we need to have or to set up a counter that counts the number of times the statement inside the loop was executed. So we name that variable to be C, and we give it its initial value to be 1. Because why 1? Because it says here that we need to sum up all the numbers from 1. So we start with 1 up to the value of n. And we also need to set up an accumulator and set it to 0. What is an accumulator? An accumulator is actually a variable that holds the running total of a value. So here the accumulator is 0. It's because we haven't have any number added to it yet. So as we go along, every value from 1 up to n will be accumulated to variable s. Then we are going to let the user input the value of n. So after getting n, we now write in our condition and we say if the value of c is less than or equal that of n. So the initial value of c is 1 here. That makes the condition true. So what we want to do is to force on the first pass of the loop, we want to force um, the the flow of your flowchart to go or enter the loop. So here it says here that is the value of c less than or equal n. So is 1 less than or equal 3, for instance. For example, if the value given by the user for n is 3, so the condition here is true. And what do we do when the condition is true? So we say s is equal to s plus c. So we add the value of our counter to that of s. And with that, the value of s changes from 0 to 1. And it keeps on going while the condition in our loop is true. Then, of course, since we want to display the sum of numbers 1, 2, 3, and so on, we need to update the value of our counter. So we need to increment the value of the counter by 1. And we have the command c is equal to c plus 1. Here, incrementing the value of 1 would control the statements or the number of times that we enter the loop. And here we say x, we make use of an on-page connector here that brings back to the conditional statement c less than or equal n. Now, when the condition becomes false, what we do is we print the value of s. And then we stop. Okay, so this is now the flowchart that would solve the given problem. Now, to check whether it would really be able to generate the correct result, let's try to trace the flowchart. So here, we have an initial value of our counter to be 1, and our accumulator, we start with 0, and we let the user input a number. So let's try a value of 5 for n. So here, we are going to sum up all the numbers from 1 to 5. Okay, so after getting the value of n, we test the condition, is the value of c less than or equal 1. So this is again substitution of the value that is on that variable. So we say is 1 less than or equal n. The condition here is true. Okay, so what we're going to do is to take the true branch here because the condition inside our decision symbol is true. Now we execute the first statement inside the loop, which is c is equal to that of s, rather s is equals to s plus c. So what is the value of s here? Initially, we have a value of 0 for s. So we have 0, add the value of c, which is 1, s now will hold a value of 1. Then we increment the value of c by 1. C is equals to c, which is 1 plus 1. C becomes 2. Then we look back, connect, going here to check again the condition if it is still true. So here, the value of c was updated, and we say is the value of c, which is 2, less than or equal the value of n, which is 5. Is 2 less than or equal 5? The condition remains true. So since again it's true, we move on to the true branch of our flow chart. Then we execute our the statement S is equals to S plus C. So that makes it what? You have S, which is 1, add the value of C, which is 2. That would give us a value of 3 for S. So S now will hold a value of 3. Then we increment the counter by 1. We have C is equals to C plus 1. What's the current value of C? C is 2, add 1, C becomes 3. Then we have an on-page connector. We look back to the condition and we say, is the value of C less than or equal n? What is C? Again, C is 3, n is 5, so 3 less than or equal 5, the condition is true. We again execute the value of S or get the value of S by adding S plus C. And what's the current value of S? It's 3. And the value of C is 3. So we add the 2. S will have a value of 6. We increment the counter by 1. So 3 add 1. Counter becomes 4. Again, we look back. We have C less than or equal 5, which is the value of n. So we have 4 less than or equal 5. The condition remains true. Again, we go back to executing the statement inside the loop, and now we have S is equals to S plus C. The current value of our S is 6 and the value of our C is 4. So we add the two, S will hold a value of 10. Then we increment the counter by 1, counter becomes 5. We look back, okay, we look back and we say, is the value of 5 less than or equal 5? It's not less than, but it is still equal 5. Now, the condition remains true. Okay, so since the condition is true, what do? We are going to, what we're going to do is, we are going to accumulate the value of our S. So we add S, which is 10, to that of the value of C, which is 5. So S now will hold a value of 15. Increment the value of C by 1. C becomes 6. And we look back. And this time, we check. Is the value of C, which is 6, less than or equal n? Is 6 less than or equal n? The condition becomes false because 6 is now greater than 5. So, which means that when the condition becomes false, we execute the statement on the false branch. So this is the statement that is outside the loop. So we execute the first statement outside the loop and it says there, print the value of S. So what it will display is the last value of S, which is 15. And it terminates our flowchart. Hope you understood how we were able to get the value of S in this discussion. Okay, so we are going to have another problem. So for a while, let me erase this one first so that we could move on to the next problem. Okay. So for the next problem, we have here, create a flowchart that allows the user to enter a password. The correct password is loop. The program should allow only 3 attempts. If the user enters the correct password within 3 tries, display access granted. Otherwise, if all 3 attempts are wrong, display access denied. Okay, so you are familiar with this type of problem as um, this is somewhat like a security problem. Okay, so let's try to solve this. Again, it says here that we only would give or allow the user to 3 attempts. Otherwise, we are going to display access denied. And we have here the password to be loop. So, you say start. And we have our counter to be equal 0. So these would be the one that counts how many times the person tried to log in. Okay, then of course we also have to initialize our password. So we say pass is equal to loop. Take note that since we are initializing a string here, we need to enclose the string in double quotes. And we are going to let the user input the password. Okay, and we name that variable p. Okay, and we say is the value of p equal to that of pass. Take note that here we are comparing two variables. We are comparing the values stored on these variables. Okay, so if the condition is true, which means that if the two passwords are equal, then we print, okay, we print, oh, I think that's too small for a print statement. Let's have this. So we print access granted. Then, of course, we stop. Okay? Because we already have granted access to the user. Now, what if the condition here is false? What do we do? So when the condition is false, we are going to increment the counter. So we say x is equals to x plus 1, which means that he was able to input a value for x or a value for the password, and the first attempt was denied. So we say is the value of x less than 3. If the condition is true, what do? If the condition is true, we look back, okay, to here to let the user input again another number. If false, if the condition is false, then we let, or rather we display print. Just a minute, let's just move this so that uh, we have, what's this? A space on to right, print access denied. And of course, after that, we have an on-page connector going here to end our flowchart. So where is our loop here? Our loop keeps on repeating here until it reaches 3. Okay? Now, let's try to um, trace this flowchart again. The problem states that we need to create a flowchart that allows the user to enter a password, and it was defined that the correct password is loop. The reason why we initialize the value of our pass to be loop. Okay? Now, the program should allow us to let the user attempt only 3 times. Okay, so if the user would be able to enter the correct password within 3 tries, then we display access granted. Otherwise, if he was not able to input the correct password, then it displays access denied. So let's trace this. Again, here, this is our counter, and we give it a value of 0. 0 because it was not able to count anything yet. Okay, then we have pass. Okay, we initialize the password to be loop, and we let the user input P. So let's say, for example, on first attempt, the user inputs the word loop, and we test, is loop equal to loop? The condition here is true. So since the statement inside the condition is true, we are going to execute the statement on the true branch, which is print access granted. And then we stop our flowchart. So what if on first attempt, instead of typing loop, the user enters loops? The condition here becomes false. Since it's false, we move on to the false branch and increments the counter by 1. So here, the value of our counter becomes 1. And why is that? Because initial value is 0, add 1, it becomes 1. And we test, is the value of x less than that of 3? The condition is true because 1 is less than 3. Since it's true, we look back and let the user input another password, or we let the user try again the second time. And let's say, for example, for the second time, he enters flowchart. So it enters flowchart and test, is flowchart equal to loop, which is stored on variable pass. The condition is false. So since it's false, we again move to the false branch and check, or rather increment the value of the counter by 1. So x is equals to 1 plus 1, x now becomes 2. And we check, is 2 less than that of 3? The condition remains true, so we let the user input again or try again to input another value. So let's say, for example, the user input um, sudo. Okay, and we test, is sudo equal to the value stored on pass, which is loop? The condition is still false. Since it's false again, we increment the value of our counter by 1, and counter here, which has a value of 2, add 1, counter becomes 3. And in the condition, we have there, is the value of x, which is 3, is it less than or equal 3? The condition here becomes false. Why? Because 3 is now equal 3. It's not less than, it's equal 3. And that makes the condition false. And since the value of x is now false, we take the false branch and we say print access denied. Then we stop the flowchart. So what happens if on the second try the user inputs the correct password? So let's say first one, it enters loops. The condition here becomes false and increments the counter. Counter becomes 1. On the second pass, let's say the user were able to enter the correct password loop. Here, when we check, is loop equal to loop, the condition becomes true. It would display access granted. So here, this flowchart that we develop would certainly be able to address or answer the given problem. So it displays access granted when the user enters the correct password. Otherwise, it displays access denied if the user tries to enter a wrong password 3 times. Okay, so hope this gives you something. You've learned something from this. And we move on to the next problem. Now let's continue and take on this next problem. Create a flowchart that asks the user to enter a 3-digit positive integer. The program must reverse the digits of the number using a loop. Now here, we are going to let the user input a number, and that number must have 3 digits in it. Then the output would be the reverse of that number. So which means that if the user would input 632, then the output should be 236. Okay, now let's start. So we have start, and we need to initialize the variables that needs updating. We have an accumulator of the reverse, which is equal to 0. Then we have the extracted digits to be also equal to 0, and our multiplier, which is equal to 100. So why do we have to have a multiplier, it's because we want that when we extract the last digit, we are going to change its position from the ones place down or up to the hundreds place. Okay, and we are going to now let the user input the number by saying input the value of n. So when the user enters n, we test if the value of n, if the value of n is greater than 99 and the value of n is less than 1000. So which means if the value of n is greater than 99, that gives us more than from 100 up, and from with the condition n less than 1000, that contains the values of n to be 100 up to 999 only. So if this isn't satisfied, which means if the condition is false, we let the user input again another number and we check if it's a 3-digit number. Now, what if the condition is true? So which means that the user enters a valid 3-digit number. So here we test if the value of n is greater than 0. And if it's true, so which means that the number or the value of n is still a 3-digit number on the first pass of this flowchart, we say d, which is our digit, be equal to the value of n modulo of 10. Okay, so here n modulo of 10 will give us what? So extract the last digit. Why is that? Because again, the modulo operator extracts the remainder of a division operation. So after getting the value of d here, we are to get the value of the reverse by saying reverse is equals to reverse plus the value of d multiplied by the value of m. Okay? So what is the value of d here? Okay, if it's 2, we multiply it by the value of m, so that would be 2 times 10, that would give us 200, and store that value to the variable rev, or the reverse value, okay, which has currently a value of 0. So adding the 2, it will give us the hundredths place of the new number. Then we divide n by 10, so that what we're doing here is to get the next two numbers. Here, when we divide it by 10, we would be working on the second and the first digit. So after, we also divide our multiplier by 10, and we say m is equal to m divided by 10. And here we loop back. Now, if the condition is false, it's wrong. I'm sorry, guys. If the condition is false, then we are now here able to reverse that number, and we say print the value of the reverse. Then we stop. So this is now the flowchart that would make us solve, or that would answer the given problem here. So let's try to trace this one, see if it would give us the reverse of a given number. Now, we have start. Again, the variable rev equals to 0 is the accumulator of the reversed value. D is the extraction of the digit, and M is the multiplier. So we don't need the D there, but I just place it there. Okay. Now, we have input the value for n. Let's say, for example, at first the user enters 27. So is the value of n 99, or rather greater than 99? The condition here is false. And is n less than or equal 1,000, or rather less than 1,000? The condition is true because 27 is less than 1,000. But since the logical operator that we use is AND, so for it to become true, both conditions should be true. Since the first condition is false, it would take the false branch and let the user input again another number. So let's try putting a value of 271. Okay, let's try to have a value 271. The condition here is true, and we let the user, or rather we check if the value of n, which is 271, greater than 0. The condition is true. So we take the true branch and we extract the first digit, or the lastmost digit, the rightmost digit of the given number, and we say d is equals to n modulo of 10. So d is equals to 271 divided by 10. What's the remainder of that? That would give us a value of 1. And we compute the reverse. We say rev is equals to rev, which has an initial value of 0, plus d, which is 1, multiplied by m, which is 100. Rev will hold a value of 100. And we divide n by 10. So 271 divided by 10 will give us 27. And m divided by 10 will give us 10. Then we look back and we test. Is the value of n, which is 27, greater than 0? The condition here is true. So since it's true, we again compute the value of d. And what is d? We say d is equal to n divided by 10. What is its remainder? So the remainder on this operation would now be 7. And that we say rev, which is 100, add the value of d, which is 7, times the value of m, which is 10. That would give us 70. And here rev now is equal to 170. Then we divide the value of n by 10. N becomes 2. And m becomes 1. Why? Because of course 10 divided by 10 would give us 1. And we look back to this condition. We check whether the value of n is still greater than 0. What is n? n is 2. Okay, so we say is 2 greater than 0, the condition is true. So we have d is equals to n modulo of 10. So what is the remainder of 2 divided by 10? The remainder is, of course, the remainder is 2. So we have to check, or rather to compute the value of the reverse, wherein the reverse is equals to the current value, which is 170, plus the value of d, which is 2, times the value of m, which is 1. So that would give us 172. And n becomes n divided by 10, that would give us 0, and m becomes 0. And we look back, we test, is the value of n, which is 0, is it greater than 0? The condition here becomes false. So we print the value of rev, which is 172, and we stop. Okay, so this is how we extract digits from a given number and add it to an accumulator for us to be able to reverse these values. Let's move on to the next problem. Create a flowchart that asks the user to enter a positive number. The program should determine whether the number is prime or not. So a prime number is a number that has two factors. Okay, so let's start. Now we need to initialize the counters that we are going to use in our flowchart. First, this counter is the possible factors that could be in a given number, and f is a counter that counts the number of factors that were found for that given number, and we are going to initialize it at 0. Now, we let the user input a value for n and test if it's equal to 1. So we say if n is equal to 1, if the condition is true, then we say that print not prime, because 1 is not a prime number because it has only one factor. And we stop. What if the condition is false? So if it's false, we test if the value of n is greater than that of the counter. Okay, and we say if this is true, so we have to check should be greater than or equal to that of the counter. So if the condition is true, we test, or rather we test if the value of the counter, or rather the value of n modulo the counter is equal 0. If it's true, that means that the counter is a factor of number n. So we are going to increment the value of the counter f. So we say f is equals to f plus 1. Then we increment the counter so that it moves on to the next possible factor, which is the value of c. So what if the condition here is false? So if it's false, we just increment the counter by 1. And here we loop back to check whether the value of n is still greater than or equal the counter. Now here, if the condition is false, we test if the value of f is equal to 2. If it's true, then we say that that number is a prime number. So print prime. Then an on-page connector here to here. Otherwise, if the condition is false, which means that you have more than 2 factors, then we have an on-page connector here. Okay, so that ends the flowchart. Now, let's try to trace this one. So counter is 1, f is 0. Let's take 1 as input. We know that 1 is not a prime number, so we test is 1 equal to 1. The condition is true, then it displays not prime, then we stop. But if we execute this and we give it a value of, let's say 7, okay, is the value of n, which is 7, equal to 1. The condition is false, so it takes the false branch, and we test is n greater than or equal c. Is 7 greater than or equal the value of c, which is 1. The condition is true. Then we go on to the true branch and we check is n modulo of c equal to 0. Is 7 divided by 1 has a remainder of 0. The condition is true. So since it's true, we increment the value of f by 1. So this is the factor counter. Our factor counter now becomes 1. And we increment the counter by 1. So counter is equals to 1 plus 1, that becomes 2. And we loop back here. Is 7 greater than or equal c? The condition is true because 7 is greater than 2. Now, since it's true, we move on again. We execute the statement inside the true branch and we check is 7 modulo of 2 equal to 0. Is 7 divided by 2? Do we get a remainder of 0? The condition is false. So since it's false, we don't increment the factor counter, but rather we just increment our counter c. So c is equals to c plus 1, c becomes 3. Then we look back. Is the number of n, which is 7, greater than or equal c? The condition is true. Is the value of 7 modulo of 3 equal to 0? The condition is false. So we just increment the counter. Counter becomes 4. We look back. Is the value of n, which is 7, greater than or equal c? Again, the condition is true. We test if 7 modulo of c, which is 4, equal to 0. Condition is false. We increment the value of c by 1. C becomes 5. Okay, then we look back. We test again, is the value of 7 greater than or equal that of 5? The condition is true. We check again, is 7 modulo of 5 equal to 0? The condition remains false, so we just increment the value of the counter by 1. Counter becomes 6. So we look back, is 7 greater than or equal 6? Yes, the condition is still true because 7 is still greater than 6. Then we test, is n modulo of 6 equal to 0? The condition is false. We take the false branch and we increment the value of c by 1. C becomes 7. We look back. Is n greater than or equal c? It's not greater, but 7 is still equal 7. The condition remains true. And we test, is 7 modulo of 7 equal to 0? Is 7 divided by 7? Do we get a remainder of 0? The condition here is true. Since it's true, we take the true branch and we increment the factor counter by 1, which has a current value of 1, so factor counter becomes 2. And we increment the value of the counter by 1, counter becomes 8. We look back, is n, which is 8, greater than, or rather, is n, which is 7, greater than or equal the value of c, which is 8? The condition here becomes false. And we test, is the value of f, which is 2, equal to 2? The condition is true. We print the word prime and we stop. Okay, which means that we are able to locate a prime number here. Now, what if the user inputs a value 4 for n? And we already know that 4 is not a prime number. But for the sake of tracing, let's take this input. So n is 4. Is n equal to 1? The condition is false, so we take the false branch and we test, is n greater than or equal c? Take note that the initial value of c is 1, f is 0. So is n, which is 4, greater than or equal c? The condition is true. And we test, is n, which is 4, modulo of c, which is 1, is it equal to 0? Is 4 divided by 1? Would it give us a remainder of 0? The condition is true. Now we increment the factor counter by 1. So f is 0. Add 1, f becomes 1. Then you increment the counter by 1. Counter becomes 1 plus 1. Our counter now becomes 2. Then we look back. Is 4 greater than or equal the value of c, which is 2? The condition is still true. Then we have, is n modulo of 2 equal to 0? Is 4 divided by 2, will it give us a remainder of 0? The condition is true. So since it's true again, we go on to the true branch and increment the value of our factor counter by 1. So 1, which is the current value of our factor counter, add 1, this gives us a value of 2. Then we increment the value of c by 1. C becomes 3 now. And we look back and test again. Is n, which is 4, is it greater than or equal c? The condition is true. Then we test the factor. Is n, which is 4, modulo of 3, would that give us a remainder 0? The condition is false. So we take the false branch by incrementing the counter value by 1. So counter, which is 3, add 1, it becomes 4. Then we look back. Is 4 greater than or equal 4? The condition is true. Then we test, is n, which is 4, modulo of 4 equal to 0? Is 4 divided by 4, will it give us a remainder of 0? The condition is true. Now, with this result, we increment again the value of f by 1. The current value of f is 2. Add 1, f now becomes 3. Okay, so f becomes 3. And we increment the counter by 1, counter becomes 5. Then we loop back. Is 4 greater than or equal C, which is 5? The condition now becomes false. So we take the false branch and we test. Is the value of f, which is 3, equal to 2? The condition is false. So we have an on-page connector displaying not prime, and we stop. So here we end our flowchart, and with this we are able to determine if a given number is prime or not.